Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science 2020 Physics Paper 2 Higher Tier. Question number 4 is on the topic on forces, mainly to do with momentum. Question 4, figure 8 shows a girl bowling a ball along a 10-pin bowling lane. The girl is trying to knock down the 10 pins at the end of the bowling lane. Velocity is a vector quantity, speed is a scalar quantity. Describe what is meant by a vector quantity and a scalar quantity. Now, a vector quantity has both magnitude and direction, whereas a scalar quantity has just magnitude only, no direction. So, the bowling lane is horizontal. Explain why the bowling ball decelerates, meaning its speed is slowing down as it travels along the lane. Now, the only reason it's going to decelerate is if there's a force acting in the opposite direction. And this force is usually coming from the drag, air resistance, or friction between the ball and the lane itself. So, there is resistive forces acts on the ball, which is usually drag and friction. So a resultant force acts in the opposite direction to the velocity. Right? That gives you just 1 mark. The first point will give you another mark, or you could say, so work is done on the ball, meaning to overcome the resistive forces. Next part, figure 9 shows the bowling ball hitting one of the pins. Write down the equation that links mass, momentum, and velocity. So again, using the equation sheet, we'll find that momentum equals mass multiplied by the velocity, or rho equals mv. Again, make sure that you get the symbols correct if you're writing the symbol equation rather than the word equation. The bowling ball has a velocity of 5 meters per second. So that's my velocity when it hits the pin. The momentum of the ball is 26 kilogram meters per second. That's rho. Calculate the mass. So using the equation, momentum equals the mass multiplied by the velocity. 26 equals m times 5. So mass equals 26 divided by 5, and that gives me 5.2 kilograms. 5.2 kilograms. Next part. Explain why the bowling ball slows down when it hits the pin. Now, why would the bowling ball slow down? You should use ideas about momentum in your answer. When they are referring to ideas about momentum, they're talking about the law of conservation of momentum, which basically states that total momentum before collision is equal to the total momentum after, meaning momentum is conserved. So if the momentum of the ball slows down, goes down, so because the ball is actually decreasing, the velocity of the ball is decreasing, the velocity of the pin should actually increase, which means the momentum of the pin should increase. So for 3 marks, you need to refer to the law. Momentum is conserved in the collision, assuming there is no external forces acting. Momentum of the pin increases. Therefore, the momentum of the ball must decrease in order to conserve the total momentum during the collision. That brings us to the end of question number 4, and I will see you in question number 5.